All right, so we're now moving on to our next unit, and we're going to be covering our first section of this unit, so section 3A, and it's going to be solving and graphing linear inequalities, and specifically linear inequalities with just one variable. And you're going to see that this is very similar to what we were doing when we were solving equations with just one variable. The only difference is now when we have an inequality, we're looking at a group of answers instead of just one. So we need to be able to not only solve, but also show it visibly through a graph. So what you'll need to know how to do, and remember, just at a basic understanding of this, is to be able to graph linear inequalities with just one variable. And then you'll also have to know how to solve one-step inequalities. And then we're going to learn something new that some of you may not have learned yet. And it's going to be solving linear inequalities through multiplying or dividing, specifically when we have a negative number out front as a coefficient. Right, because there's a special rule and a special thing that we have to do when we're solving inequalities where our coefficient is a negative value. So those are the three things that you should know how to do by the end of this video. And remember, it's just a basic understanding of it and not expecting you to be able to master it just because you watch this video. But let's go ahead and get started with the graphing of inequalities first before we get to solving. All right, so we're going to go through these four examples pretty quickly because this shouldn't be new for any of you who are graphing these inequalities. So remember, when we are getting an inequality, this less than or this greater than sign, remember we read them left to right, it's actually giving us a range of answers or solutions. This is saying x is less than 3. So any number that is less than 3 is a solution to this, from ranging from negative 100 million all the way to just 2. So any number that is less than 3 will be a solution. So when we see here, we see that we have, we're going to graph these two first, where they're both less than, but this one here, when we had the line underneath, it means less than or equal to. So for this one, 3 is not a solution because 3 is not less than 3, so that is not a solution. However, for this one, since it says less than or equal to 3, it is a solution. So since these are almost identical, but there's one slight difference in that 3 can be a solution because it's equal to, when we graph these, we need to make sure that we are graphing them properly so that this way the reader knows, okay, the 3 is not included in this one because it's not equal to, whereas the 3 is included for this. So when we have just less than, when we go to graph, the first thing that we need to do is we're going to draw an open circle at the value that x is less than. So here, x is less than 3, so it's going to be an open circle. When it's less than or equal to, it is a closed circle at that value. So here we will put a closed circle at 3. So when a reader goes to look at this, when they see an open circle, they know that we're not including 3 as an answer because it's not solid. It's not representing that 3. All right. And here, when it is colored in, it's telling us that it's less than or equal to, so it is included with that answer. All right. So when you're graphing, the first thing you do is you need to isolate your variable x all by itself. So you get x or y, whatever it may be, all by itself. And then whatever value it's less than or equal to or greater than or equal to, you are going to plot a point at that value. So here we plotted 3 for both of those. And it splits our graph into two different regions at this 3. We have values to the right of it and values to the left of it in both cases. Right. So one of the things that I do think you should get in the habit of doing, because it does make it easier for you when we're going to do what's next when we're graphing linear inequalities with two variables, is we're going to pick points and test them. So I'm going to pick 0 and 5, and I'm going to plug them back into my original problem, see which one's actually true. Is 0 less than 3 or is 5 less than 3? So 0 is less than 3 and 5 is not. So that means that every single number in this region does not satisfy our inequality, because if one of them will satisfy in that region, they all will as well. So from here, since 0 was less than 3, that means that my arrow needs to go in the direction of 0. So my arrow need to go to the left because it's covering where my 0 is on the number line. So this is the way that x is less than 3 will be represented. And then from here, x is less than or equal to 3. Well, we have the colored in circle, and the same thing. We pick 2 points. I'm just going to pick them again. 0, is this less than a 3? And 5, is this less than a 3? And the same thing, the 5 does not work, so we know that this side of our region is not going to be a solution, but 0 is less than or equal to 3, so we can then go ahead and draw our graph going in that direction. All right, so we can pick points and plug it back into the problem and see, well, which one's true and which one's false? And whichever one is true, that's the way that we're going to be drawing our line. All right, so the same thing here. I see that this is just greater than and not equal to, so it's going to be an open circle at 3. And this one's greater than or equal to, so it's going to be a colored circle at 3. So now, once again, it splits my region up into two, or my graph up into two different regions. And I'm going to pick points, same points I'm going to pick, 0 and 5. I'm going to plug them in. Is 0 greater than 3, or is 5 greater than 3? Well, 0 is not, so I know that this region is not going to be a solution. And 5 is greater than 3, so I'm going to draw my graph going in the direction of 5, which is to the right. All right, and then once again, I'm going to plug in the points 0 and 5 into this one. Is 0 greater than or equal to 3, or is 5 greater than or equal to 3? And 5 is, and 0 is not. So that means my graph is going to go to the right, the region in which 5 was, and this is the way it's going to look. So when we're graphing, the first thing we need to do is identify our sign. Is it just less than or greater than, or is it equal to as well? And if it's equal to, we need to make sure that we are doing a colored in circle for our point. And if it's just greater than or less than, it is an open circle because it means it doesn't include that value. All right. And then from there, once we isolate our variable x, we then are going to plot that point on our number line, which then separates our region. And then we are going to test values to see which way is our graph going to go, to the left or to the right. All right, there are other ways for you to identify which graph it goes without needing to plug in, but because I want us to practice this for our the last part of this unit, I'm not going to discuss any of those other ways, but if you already know them, you can go ahead and use them as well. All right, so let's go ahead now and go solve some problems. All right, before we go ahead and solve some problems, I actually just want to go through just a few things with you real quick. So if we have a statement that 10 is greater than 5, and we agree that 10 is greater than 5, if I add the same number, and I'm just going to represent that by a, if I add the same number to it, that 10 plus a will always be greater than that 5 plus a because we're adding the same number to both sides. And if one number was greater to begin with, then that means that when we add the same number to both sides, that same number will continue to be greater because it was already greater to begin with. And if we're adding 10 or 15 to both sides, they're both increasing by the same amount. So therefore, this side will remain bigger, right? So when we're adding, it doesn't change anything to our inequality. Whichever side was larger to begin with will always remain larger. And the same thing will hold true when you subtract as well, because if we have 22 is less than 81, regardless of whatever number I subtract, that 22 minus that number will continue to be less then whatever will continue to be less than the other side of our inequality because we're subtracting the same number from both sides. So since we're removing the same amount from both sides, the side that is larger will always remain larger with that. All right. So when we're adding or subtracting in our inequalities, there's nothing that happens within our problem. It's just like we would with an equation, except for we will have a group of answers instead of a single answer. All right. So just remember that whatever side is larger to begin with, when we add or subtract the same number from both sides, that will remain larger as well. All right, so let's go ahead and do just one or two quick questions for this before we move on to multiplication. All right, so the directions for these problems are solve the given inequality, then graph the solution. All right, so when we do this, we do it just like we would have as if this was an equation. So we look and say, okay, what is happening to our variable? And it's being added with 8. So we ask, okay, what is the inverse operation of addition? And that's subtraction. So we'll subtract 8 from both sides. And then these will cancel out. So now we have x is less than or equal to 5 minus 8 is negative 3. So before we can graph, we have to solve for it first, which means we need to get x isolated all by itself. So some of the common mistakes that people will make is they will try to graph before they solve. And then they'll graph that it's less than or equal to 5. So make sure you isolate your variable before you go ahead and graph anything. Then once we get our variable isolated, now we need to graph. And this is what your graphs will look like. I'm not going to give you the numbers because I'm kind of telling you where the answers are. So once you finish isolating your variable x, I'm just going to fill in this number line. So in the middle, I'll put whatever my number is, so negative 3. And then I'm just going to go ahead and fill in the rest of this number line by adding 1. And if you want to add by 2s or whatever you may be, you can. But it's just easier just to add and subtract each side by 1. So now I create my number line. And once I isolate it, that's the number I'm going to then plot, or where I'm going to plot my point. And the first thing I need to look at is what type of inequality do I have? And since it's equal to, I know it's going to be a colored in circle. And when you graph these for me, please put them above the number line so it's easy for me to see. If you put them on the number line, it could be hard for me to see which way you draw your graph. And if I can't tell which way you're graphing with your drawing, I can't guess with what I think your answer is. So draw it above so it's just nice and easy for me to see. So it's going to be a colored in circle at negative 3. So that's then going to put our graph into two different regions. So I'm going to pick 2 points. So I'm going to pick 0. It's the easiest number to put in. And I'm just going to go ahead and pick, I don't know, let's say -5. Right now, you can plug it back into your answer, but if you made a mistake somewhere, you're not going to find that if you plug it into your answer. So, what I would suggest you do is plug these back into the original problem. So, we'll see, is 0 plus 8 less than or equal to 5? Well, 0 plus 8 is 8, and 8 is not less than or equal to 5. So, we know that this region is not going to be our solution. So then we'll plug in -5. -5 plus 8, is this less than or equal to 5? Well, -5 plus 8 is going to give me 3, and 3 is less than or equal to 5, so that does work. So then that means that this side of the region, the graph, is a correct answer, so that means all of them will be, and my graph will go to the left. The only number that you can never pick is the number that's splitting your region up, so we'll never pick 3, or -3 in this case. All right, so now let's go ahead and move on to example 2. Same thing, in order for us to graph this, we need to solve it first. Well, it's being subtracted by 21, so I'm going to add 21 to both sides, and now I get the inequality that x is greater than 51. So I'm going to go ahead and put 51 on my graph, and I'm going to just count by count by ones, and once again, you can count by twos, and going to then identify, well, what type of point am I going to have? So since it is just greater than and not equal to, that means it's going to be an open circle. So I'll put an open circle at 51. This is going to split my graph into two different regions, and I'm going to pick 2 points. I'm just going to pick 50 and 52. So now I'll test them. 50 minus 21, is this greater than 30? Well, 50 minus 21 is going to give me 29, and 29 is not greater than 30, so no, this side of the region does not work. Then I'll plug in, does 52 minus 21, is this greater than 30? Well, 52 minus 21 is 31, and 31 is greater than 30, so yes, that side of the region works. So my graph will have to go to the right where my 52 is at. All right, so now I'm actually going to end the video here for this one, and then we're going to pick up with the second video. This is going to go over multiplication, and then this way the videos can be a little bit shorter rather than watching one really long video.